everyone, welcome back to another new video. In today's video, I am going to solve square root of a number. And in this video, first we explain the problem statement, then we explain the approach and with implementation using examples, then we explain the code and time complexity and space complexity both. Okay. And before starting today's video, please like and share. And if you are new, please subscribe. Go to problem statement. In problem statement, you have given an integer n and you have to find the square root of n, and if n is not a perfect square, then you have to return the float value. And float value of any number is the greatest integer which is less than or equal to that number. Less than means float value will be equals to our input value, which will, that will be equal to that value or less than that value. Okay, so go to first example. In first example, given input value is n equals to 5. Okay. Now we have to first check n is perfect square, 5 is 5 perfect square or not. Okay. And you can see 5 is not a perfect square. We can't make a square from 5. Okay. And for this, we have to choose the nearest perfect square of 5. The nearest perfect square of 5 is 4, because if you root 4, value will be, it is a perfect square 2. So this 4 root 4 is perfect square. And also in, if you search in calculator, calculate root square root 5. Square root 5 is 2. 2.23606. Okay, so we consider the integer value, not float value. So for this, we will consider these two. Okay, we will consider remaining value. So it is another case. So in this case, output will show floor value of 2. Okay, n equals to 5. This 5 is not a perfect square, so it will return the floor value 2. Okay. Now go to next example. In next example given n equals to 4, and a 4 is perfect square. Okay, how? If you root over 4, what we will get? 2. Root over 4 square is 2 value. Okay, so in this case we have find perfect square value. So in this case it will return the perfect square value. So output will be 2, because it is a perfect square value. Okay. Now, what is the approach of this? Approach basically, we use binary search in this problem statement, and first we use base cases for the given problem. When the given number is 0 or 1, then we return x. X here they have written x. X means this n. Okay, this n, this input n, they are considered as x. Okay, so then we create some variables for sorting the lower bound, like say L equals to 0 and upper bound R equals to x by 2, and the floor value of the square root x cannot be more than x by 2 when x greater than 1. Okay, and then we create a loop until lower bounder is less than equals to upper bounder. It will create this loop. It will check this condition. Okay, and it will search the space vanishes, and then we check the, if the square of mid value is less than or equal to x, the square of mid value is less than equals to x means n, and if yes, then the search for a larger value in the second half of the search space, and after that else it will be the square of mid is more than x, and then it will search for smaller value in the first half. Okay, and if what is it, so it will maintain this, basically these two condition, it is very important, these two plus 2 point. If check square of mid value is less than equal to x, then if it is, then it will search the larger value of the second half, and if it's not, then it will search the smaller value in the first half. Okay, now, what is the time complexity of this? Time complexity will be O of log n. Here they have written, they have considered n equals to x, in consider as x. So in our case, time complexity will be o of log n, and space complexity will be o of 1, o of 1. Okay, o of 1. That's now in code. In code, basically what we do, first we check the base cases for special cases. Okay, for special cases we check if n equals to 0 or 1. If we can n equals to 0 or 1, it will return the n. Okay, and then it will check the store the floor value of square root. As for this, we initialize two variable high and low, and then we create a binary search loop, while loop. While low boundary is less than equals to high boundaries, then it will calculate mid value. Okay, middle value, low plus high divided by 2. We know how to find middle value. Okay, and if middle value into middle value exactly n, then it will return the mid value, and if not, then it will run this condition, and else it will, if mid into mid is greater than n, then it will discard the right half. So we write down high equals to mid minus 1, and after that it will return the floor value after binary search complete. Now go to code. Okay, compile and run, and now submit. And we will successfully solve today's problem. Hope so today's video is helpful to you. See you in next video. Till then, tada, bye bye.